If it goes through the keyhole, it will hit us April 13th, 2036. The chances of this now, our data tell us, is several in a million. But there are people who buy lottery tickets with worse odds than that, expecting to win. It'll hit Santa Monica, it'll explode, 50 feet tsunami, 5-story tall, that will come to the west coast of North America and basically wipe it clean.
Imagine cruising through a vast space minefield. That's pretty much what Earth is doing every day. Neil deGrasse Tyson, a big shot in the world of astrophysics, gets the heebie-jeebies when it comes to asteroids. And honestly, it's easy to see why. These aren't just the stuff of epic sci-fi movies, they're real, and they're out there zipping around in space. We're talking about chunks of rock and metal, leftovers from the solar system's early days, some of which could be on a collision course with our planet. But what exactly are we dealing with here? Well, it's a mix. You've got asteroids that are no bigger than pebbles, and then you've got the big kahunas, ones that are the size of mountains or even larger, and they're all just floating around in space, following their paths around the sun. The thing is, their orbits can be a bit like a pinball machine, unpredictable and at times downright dangerous for Earth. These space rocks are fascinating in a way. They're like time capsules holding secrets from billions of years ago when our solar system was just taking shape. But they can also be a bit scary. After all, a big enough asteroid smacking into Earth could be bad news. We're talking about potential global consequences, from tsunamis and earthquakes to climate changes that could really shake up life as we know it. Have you ever thought about the times Earth has played cosmic dodgeball with asteroids? Let's talk about some of Earth's most dramatic run-ins with these space rocks, starting with a biggie, the Chicxulub impactor. Picture this. About 66 million years ago, a giant asteroid, about 10 kilometers across, comes hurtling towards Earth. It crashes into what's now the Yucatan Peninsula in Mexico, and boom! It unleashes energy like billions of atomic bombs, creating a crater 150 kilometers wide and 20 kilometers deep. The aftermath? A global climate shakeup, and about 75% of Earth's species, including the dinosaurs, say their final goodbyes. Fast forward to a more recent event, the Tunguska explosion in 1908. This wasn't a direct hit, but it was still a showstopper. An asteroid or comet fragment, maybe about 50 to 60 meters wide, bursts in the sky over Siberia. The blast, with the power of 10 to 15 megatons of TNT, flattens a whopping 80 million trees across 2,150 square kilometers. That's an area bigger than some major cities. And get this, there was no crater found. Scientists think the object just blew up mid-air, about 5 to 10 kilometers above the ground. The Tunguska event is a bit of a cosmic wake-up call. It showed us that these space rocks can be pretty sneaky and unpredictable. It wasn't like we had a heads up to brace ourselves. This unpredictability is why keeping an eye on the sky for asteroids is super important. You never know when the next big one might make an unwelcome visit. Let's get into the fascinating world of asteroid tracking, where scientists become cosmic detectives. Imagine trying to keep tabs on space rocks cruising through our solar system, some of which might get a bit too cozy with planet Earth. This task is a blend of astronomy, physics, and some serious sleuthing. So how do you track a hunk of rock zipping through space? First, you gotta spot it. Scientists use beefy telescopes, both chilling on Earth and orbiting in space, to catch a glimpse of these celestial wanderers. Once they've got an asteroid in their sights, it's all about measuring where it is, how bright it is, and how it's moving compared to the stars. This info helps work out the asteroid's orbit, speed, size, and where it might be heading. The process, called astrometry, is like celestial cartography, mapping out the positions and paths of these space rocks. But spotting an asteroid is just the start. Predicting where it's going to be in the future is a whole other ball game. It involves some hefty math and computer simulations. Scientists juggle the laws of how celestial bodies move and toss in factors like the pull of gravity from other planets, the asteroid's own twirl and shape, and even how the sun's heat gives it a gentle nudge, something known as the Yarkovsky effect. One of the big players in this game is NASA's Near-Earth Object Observations program. These folks are on a mission to find and track at least 90% of the near-Earth objects out there that are 140 meters or more in diameter, the kind of rocks that could really ruin our day if they hit us. Then there's the European Space Agency's Hera mission, gearing up for a 2024 launch. Hera's going to take a close look at the Didymos asteroid system and its little buddy Dimorphos. It's like a follow-up gig to NASA's DART mission, which is testing out if we can actually shove an asteroid off its course by ramming a spacecraft into it. But here's the kicker. Tracking asteroids isn't a walk in the park. There are loads of them we haven't even found yet, and some are tough to track because they're small, dark, or zipping around super fast. Plus, space is huge, and asteroids are like needles in a cosmic haystack. Have you ever thought about how Earth has had some really close calls with asteroids? These near misses are like nature's warning shots, reminding us that we're just a tiny part of a vast, dynamic universe. Take the Chelyabinsk event in 2013, for example. This was a real eye-opener. A relatively small asteroid, just about 20 meters across, came out of nowhere and exploded over Chelyabinsk, Russia. The blast was massive, releasing energy around 30 times greater than the Hiroshima bomb. It wasn't just a light show. The shockwave broke windows and even damaged buildings, injuring over 1,000 people. It was like a scene from a movie, but very real and pretty scary. This event showed us that even a small space rock can pack a massive punch, but Chelyabinsk isn't the only time Earth had a narrow escape. Let's rewind to 1908, the Tunguska event. An asteroid or comet fragment blew up over Siberia, flattening about 80 million trees over a massive area. It's like Mother Nature showing off her power. More recently, in 2021, we had asteroid 2001 FO32, about 900 meters in size, cruised by Earth. It was 2 million kilometers away, which sounds like a lot, but in space terms it's pretty close. What's tricky about these cosmic wanderers is that they can be hard to spot. They're like stealthy space ninjas, small, dark, or sometimes hidden by the sun's glare. This makes predicting their paths quite challenging. Scientists are constantly on the lookout for these elusive space rocks. Projects like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona are like our cosmic watchtowers. They're scanning the skies, trying to spot any potential threats. And then there's NASA's NEOWISE mission, using an infrared space telescope to find asteroids that might be too dark for regular telescopes to see. But here's the catch. Our tech isn't perfect. We're pretty good at spotting the big asteroids, but the smaller ones, like the one that hit Chelyabinsk, can slip under the radar. With millions of these small near-Earth asteroids zooming around, it's a bit like finding a needle in a haystack. Now let's wade into the mysterious world of asteroid impact conspiracy theories. It's a place where wild speculation meets a sprinkle of imagination, and sometimes it can clash pretty hard with scientific facts. These theories have a bit of everything, from hush-hush government secrets to alien shenanigans. One popular tale you might hear whispers about is that governments or big space agencies, like NASA, are sitting on a goldmine of secret info. They supposedly know about a doomsday asteroid on a crash course with Earth, but are keeping it on the down low to prevent mass panic. It's a theory that could be straight out of a thriller movie, but when you shine the light of science on it, it kind of falls apart. Here's the thing. Keeping an eye on asteroids is a huge international effort. We're talking about a network of observatories and agencies all around the globe, constantly watching the skies. Keeping a secret of this magnitude under wraps, highly unlikely. Then there's this other out there idea. Some asteroids zipping through space are actually alien spacecraft or probes under the watchful eye of extraterrestrial beings. It's a theory often fueled by the weird shapes or paths some asteroids take. But in the world of astronomy, these oddities usually have more down-to-earth explanations like natural erosion, cosmic smash-ups, or just the simple tug of gravity. And let's not forget about the theories that suggest some shadowy groups or governments are cooking up secret plans to either weaponize asteroids or use them for some sort of space-age power play. While the idea of redirecting asteroids is a genuine scientific pursuit, the notion of using them as cosmic weapons is more sci-fi than science fact. It's important to remember that these conspiracy theories, as entertaining as they might be, can sometimes cast a shadow over the real, critical work happening in asteroid tracking and planetary defense. This field is all about open collaboration and sharing knowledge. Scientists from around the world team up, share their findings in peer-reviewed journals, and keep databases like the Minor Planet Center up to date with the latest asteroid orbits. Plus, there's Asteroid Day, an annual event where space experts gather to spread the word about asteroids. It's all about education and transparency, showing just how open the field of asteroid research really is. So while it's fun to entertain these space rock conspiracies, the truth is often more grounded and collaborative. It's a global effort where scientists are the real heroes, working hard to keep our planet safe from any unwelcome cosmic visitors. What if I told you that we're actually cooking up plans to save Earth from a Hollywood-style asteroid catastrophe? It's true. Scientists and engineers are working on some pretty cool strategies to deflect a rogue asteroid heading our way. This isn't sci-fi anymore, it's real science in action. Let's start with the big guns, nuclear deflection. Now, this isn't about blowing an asteroid to smithereens like in the movies. Instead, it's about setting off a nuclear explosion near the asteroid to gently push it onto a different path. It's like giving the asteroid a little nudge away from Earth. This could be a game changer for dealing with big asteroids, but it's also a bit controversial. There's the whole unpredictability of nuclear blasts in space and the risk of breaking the asteroid into smaller, yet still dangerous pieces. Then there's this super cool idea called kinetic impactors. Think of it as playing interstellar billiards. We send a spacecraft to smash into the asteroid at high speed, which changes its course. NASA's got this project called DART, the Double Asteroid Redirection Test, where they're actually going to try this out. They're planning to whack a spacecraft into an asteroid's little moon to see if they can change its orbit. It's like a real-life experiment to test out our planetary defense skills. Another nifty idea is the gravity tractor. Picture a spacecraft just hanging out near an asteroid for a long time, using its own gravity to slowly but surely pull the asteroid into a safer orbit. It's a slow and steady approach and less likely to break the asteroid apart. But it's a bit like watching paint dry, it takes a long time. And get this, some folks are thinking about using solar sails or even lasers to push asteroids away. These methods are more about gentle nudges than big shoves. NASA, the United States Space Agency, has made numerous discoveries over the years, many of which have expanded our understanding of space, our solar system, and the universe. While most of these discoveries are awe-inspiring and enlightening, there have been a few that could be considered disturbing depending on one's perspective. Here are some of the most intriguing and potentially unsettling discoveries. Near-Earth objects, or NEOs as we often call them, are these fascinating and sometimes intimidating visitors from our solar system's backyard. Think of them as cosmic nomads that have been nudged by the gravitational pull of planets, bringing them into Earth's neighborhood. These NEOs are a mixed bag. Some are comets made mostly of ice with a sprinkle of dust, creating those stunning tails we see in pictures when they're close to the sun. Then there are asteroids, the rocky ones, leftovers from the solar system's early days. Now picture this. These NEOs are on all sorts of orbits, some stretching out in long, drawn-out paths that bring them swooping close to the sun and, by extension, to our own planet. This is where it gets interesting and a bit unsettling. When we think about what these NEOs could do if they crossed paths with Earth, it's like a cosmic game of roulette. NASA and other space agencies keep a close eye on these celestial wanderers. They use telescopes both on the ground and in space to track their movements and predict where they're heading. It's a complex dance of calculations, taking into account the push and pull of gravity from other cosmic bodies. Now let's talk about the impact scenarios. Small NEOs, those less than 25 meters in diameter, usually burn up in our atmosphere. But remember the Chelyabinsk meteor back in 2013? That was a small one, and it still caused quite a stir with its shockwaves. Then we have the medium-sized NEOs, ranging from 25 to 140 meters. If one of these hit Earth, we're talking about serious regional destruction, like creating massive craters or even triggering tsunamis if they take a dive in the ocean. And let's not even start on the large NEOs, those over 140 meters. They're the real heavy hitters, capable of causing global catastrophes. Think dinosaur extinction-level events. Speaking of which, let's roll back the cosmic clock to the Cretaceous-Paleogene extinction event 65 million years ago. That was one massive asteroid that left the Chicxulub crater in Mexico. It's widely believed to have wiped out the dinosaurs along with a host of other species. Then there's the Tunguska event in 1908. A smaller NEO exploded over Siberia, flattening an enormous area of forest. It's a stark reminder of the power these space rocks hold, even the smaller ones. But when we start talking about the bigger ones, the medium to large NEOs, it's a whole different story. These guys are rarer, luckily for us. We're talking about something that happens maybe once in thousands or even millions of years. But if one of them decides to make an unexpected visit, it's big news. We're talking about events that can really shake things up on Earth, like the one that made the dinosaurs history. Now, you might be wondering, can't we just predict when these space rocks will come calling? Well, despite all our fancy technology, it's still quite a challenge. The smaller NEOs are especially sneaky. They're tough to spot until they're almost on top of us. It's like trying to spot a firefly in a rock concert from the back row. But don't worry, we're not just sitting ducks here. There are some pretty cool ideas out there to prevent a cosmic smash-up. Scientists have thought about using what they call gravitational tractors, basically tugging an asteroid onto a different path. Then there's the idea of smacking it with a kinetic impactor, kind of like playing cosmic billiards. And if things get really serious, we could even go a bit Hollywood and think about using nuclear explosions to nudge them off course. It's like something straight out of a sci-fi movie. This is where teamwork comes into play. This is a global affair. Organizations like the United Nations are in on this, discussing how countries can share info and work together if a dangerous NEO is spotted. It's like forming a planetary defense team, just like in the movies, but for real. Keeping the public in the loop is key too. It's important that people understand what NEOs are and what risks they bring. And hey, who doesn't want to be prepared for an asteroid strike? Governments and agencies are working on plans for what to do if one of these space rocks has Earth in its sights. And the quest for knowledge continues. NASA and other space agencies keep their eyes peeled, watching the skies for any new NEOs and keeping tabs on the ones we already know about. Missions like NASA's OSIRIS-REx and Japan's Hayabusa 2 are even going out there, visiting these NEOs, getting up close and personal, bringing back souvenirs, samples, for us to study. Now, moving on. Imagine this. We're living in a universe where the story of Goldilocks and the Three Bears takes on a cosmic twist. In our sky, there are these special places around stars, known as the Goldilocks zone or the habitable zone. It's not too hot, not too cold, just perfect for liquid water, which we think is essential for life. Now that's a big deal because where there's water, there could be life as we know it. Now let's talk about how we find these potentially habitable exoplanets. There's this really cool method called the transit method. It's like when you're at a cafe and someone walks past the window, casting a shadow. Astronomers look for these shadows across stars to find planets. It's especially good for finding planets that like to snuggle close to their stars. But wait, there's more. There's also this thing called the radial velocity method. Imagine you're watching a friend on a merry-go-round. As they move towards and away from you, their speed seems to change. That's what astronomers look for in stars. They measure this wobble, caused by the gravitational tugs of orbiting planets, to find these hidden worlds. Now, let's talk discoveries. NASA's Kepler mission was like a planet-hunting superhero. It found thousands of exoplanets, many in habitable zones. One of its coolest finds was Kepler 452b, nicknamed Earth's cousin. Why? Because it's eerily similar to our home and sits comfortably in its star's Goldilocks zone. But the story doesn't end there. Enter TESS, the Transiting Exoplanet Survey satellite, which has a knack for finding exoplanets around the brightest stars. These are easier to study, giving us a better chance of understanding these distant worlds. And then there's TRAPPIST-1, the rock star of exoplanet systems. It's got 7 Earth-sized planets, with several in the habitable zone. It's like a cosmic jackpot, offering us a unique chance to study these worlds, peering into their atmospheres and, who knows, maybe find signs of life. So let's dive deep into the rabbit hole of what these exoplanet discoveries really mean for us, in a way that would make your head spin. First off, we've got these potentially habitable planets out there, and they're shaking up our whole understanding of the universe. It's like we've been living in this cosmic bubble, thinking Earth is the only place for life. But now we're looking up at the stars and realizing we might just be one of many. This isn't just science talking. It's a philosophical mind-bender. It's got people thinking and rethinking about everything from our special status in the universe to the big questions of creation itself. And then there's the whole theological angle. These discoveries are sparking some major conversations in religious and spiritual communities. It's like we're opening a new chapter in the book of creation, one where life might be scattered across the cosmos. It's a game changer, making us ponder the nature of divine creation and our place in it. Now let's talk about the hunt for ET. The search for extraterrestrial intelligence, or SETI, is out there, scanning the skies for any hint of alien chit-chat. It's like trying to tune into a cosmic radio station, hoping to catch a snippet of conversation from a civilization light years away. And the excitement's only going to ramp up with missions like the James Webb Space Telescope. This beast of a telescope is our ticket to peeping into exoplanet atmospheres, sniffing around for signs of life like water, oxygen, and maybe even little green guys. Okay, maybe not green, but you get the idea. But hold on, it's not just about finding life, it's about understanding life in all its wild and wonderful forms. Astrobiologists are having a field day with this. They're brainstorming about what life might look like on planets that are nothing like Earth. Think of it as biology, but with a sci-fi twist. And they're not just making wild guesses. They're looking at everything from the size of the planet to the type of star it orbits to figure out where life could pop up. But here's the kicker. What if we actually find intelligent life out there? It's a mind-boggling thought. How would we react? Would we reach out, say hello, and invite them over for cosmic coffee? Or would we keep our distance, just peeping through our cosmic telescope? It's not just a scientific question, it's an ethical and philosophical puzzle. And then there's this idea called the Great Filter. It's this theory that says, hey, maybe the reason we haven't found alien life is that there's some kind of cosmic roadblock that wipes out civilizations before they can phone home. It's a bit of a downer, but it's got scientists thinking about what that could mean for our future. Lastly, we've got to think about keeping our cosmic backyard clean. With all this talk about finding and maybe even visiting other planets, we've got to be super careful not to track our earthly germs all over the universe. It's like interstellar environmental protection, making sure we don't mess up other planets and they don't mess up ours. So what does all this mean? Well, it's changing the way we see ourselves in the universe. Every new planet we find in these habitable zones is like a new story waiting to be told. Could they host life? Are we alone?